Starting with chapter 2, what we're going to do is talk about how we solve an equation with a single variable in it. So most of the time we'll see it as x, but again, no like mix of it in a degree of 1. Start with a couple of definitions. We talked a little bit about this. We're going to see an equation, which is a statement that two expressions are equal to each other. And we're going to see that kind of divided with that equal sign. So we'll have an expression on this side, just kind of show you binomial, and it will equal another expression on the other side, maybe like 7 minus x. Okay, so this is an expression, this is an expression, the whole thing is an equation. What we are going to talk about is a linear equation, which is a first degree equation, and that is when the exponent in the equation, the highest one, is a 1. And you can see here the variable is x, and even though there's not a number written there, there's an imaginary 1. And that means that the degree is 1. Okay, degrees come from exponents. And having a degree of 1 means that it's going to be linear, meaning just a nice, straight, constant line. We'll talk about slope a little bit later, but it rises and runs the exact same way all the way across the line. The solution is when a variable in the equation is replaced by a number in the resulting to the equation to be true. So that's what we're trying to do. We're going to be solving something to find what that variable value is, and that should be able to be plugged back in, tested to make it true. So if we look at the first couple examples, what we're going to do is, again, the goal is to get the variable by itself. And what you want to do is you want to get rid of everything else on that same side. And you do that by doing the opposite operation. And I usually try to work my way towards the variable. So we start kind of reverse operations. You want to get rid of that 6. So to undo that, I subtract. So we subtract 6 on both sides. The 3x drops down, and that equals 6. To get rid of the 3 in front, we divide because this is multiplication in here. And our solution is 2. Now, we can write it in set notation. Okay, our solution set is 2. What I do want you to do is I want you to do a check. Put it back in for the x value. Make sure it's correct. So 6 plus 6, that equals 12. 12 equals 12, that is true. So basically, you should be able to go through a test or a quiz and feel confident that you got every single question correct. Now, the variable could be on different sides of the equation. So again, what we're trying to do is we're trying to get this by itself. Working my way towards it, I want to get rid of the 3. So we're going to subtract 3. And what we're going to get is 1.5 equals 2.5x. Okay, that's going to cancel out right there. And then to get rid of the 2.5, we divide both sides by 2.5. This will cancel out. Now, I have 1.5 over 2.5, and we talked about this earlier. We don't want to have decimals within fractions. So I can move the decimal over 1 by multiplying both the numerator and the denominator by 10. So 15 over 25. And then reduce that. We always want to reduce. So divide by 5. 3/5 will be my answer. Again, what I would like you to do, pause the video, take out your calculators, and put in 3/5 into that x, or 0.6 if you want, and make sure that checks out. So in this case, what we see is that we see variables on both sides of the equation. What we want to do is we want to kind of merge them together on each side individually first, and then what we want to do is bring them to the other side. So you can kind of see how that equal sign kind of splits the two sides. When I start on the left and bring together the x's, so that's negative 5x plus 2, And over here, what we can do is take the 8x and the minus 7x, and that's 1x. And now we simplified both of those sides, but I need to bring the x's together. So I can either add 5x to both sides, or I can subtract x. I'm going to choose to add 5x. It's going to cancel here. And we're going to get 2 equals 6x plus 20. Now I want to get that x by itself, so I'm going to subtract by 20. And we're going to get negative 18 equals 6x. Divide by 6, x equals negative 3. Again, we want to double check this. So when I go to double check, I don't go to my simplified version. I'm going to go straight to the original problem to make sure I didn't make a mistake early on. So I go right to the original, and every time you see that x, you are putting in a negative 3. And then what you're going to do is you're, again, just checking your arithmetic, making sure it's correct. So 6 plus 2 plus 9, that's negative 24 plus 20 plus 21. So this will be 8 plus 9, which is 17. Negative 24 plus 20 is negative 4, plus 21, that is 17. So that checks out. I would like you to pause the video and try to solve number 4 by yourself. When you're done, unpause it and make sure that you have it correct. So the answer you should get is 1. If you had something different, make sure you pause it and fix your corrections from the work on the screen. We're going to need to make sure that we're comfortable working with fractions through this year. Many times throughout the year, we're going to have problems with fractions on them. What I always try to do is if I have an equation with fractions in it, I want to find the LCD. So in this case, the LCD is going to be 24. So 6 and 8 can go into 24. And what I do then is I'm going to create the same denominator. So I do that by multiplying by 4 on this one, by 3 on this one, and by 3 on this one. So notice I multiplied the numerator and the denominator. We get 4x over 24 minus 3x over 24 equals 3 over 24. By getting the exact same denominator, we can actually clear it out by multiplying by the denominator. So if I multiply both sides of the equation by 24, this is going to cancel out, and when I distribute this, the denominators cancel out. And you end up with this really nice looking basic equation. So x equals 3. Again, I would still double check, put that back in, make sure it works out okay. I'd like you to pause the video one more time, and I'd like you to actually work on 6 and 7. You might find that these may have some tricks to them. I want you to think about what that actually means and how you would write that solution. So in the first one, when you see that you distribute and you start to bring the 5x's over to each side, you notice the 5x's cancel each other out, and there's no more variables. And you end up having 0 equals 16. Well, there's no variable to solve for, and this right here, this is a false statement. Since this is a false statement, this results into the idea that there is actually no solution that would work. There's no number that I can put in here or here that's the same number that would make the statement true. So I can write no solution. I can write it as the empty set. They mean the same thing. But again, when the variables cancel out, it means no solution. Number 7 has a very similar feel to it. You'll notice that the 4x's cancel out and there's no more variables. But this time, what results is that the statement is true. When the statement is true, that means every single number would work. Think about this. If I put in the number 2 right here, Negative 4 times 2 is negative 8, plus 4 is negative 4. Negative 4 times times 2 is negative 8. Minus 9 is negative 17. Plus 13, that's 4 again, negative 4 again. You pick your own number and you'll see that it works out just the same way. So that means any single number would work. So true statement results in all real numbers, and I can write this kind of as an R with a double line next to it.